We're going to go ahead and start today's notes. We are going to continue on comparing and contrasting linear, exponential, and quadratic formulas. So if I go ahead and go here, we can go ahead and talk about how to find and match a function given a description. Now, before I go ahead and start I will determine what each function is. So for example, if you look here, I'm going to go ahead and use highlighters. So I'm going to color, there's that, green and blue. I'm going to go ahead and color all my quadratic functions in yellow, all my exponential functions in green, and lastly, my blue are going to be my linear functions. Now we have to be able to determine which function we have given a special circumstance. Remember, when we're looking for a quadratic function, we always have to look for the exponent of 2. When we're looking for exponential, we always have to look for the exponent of x. And when we are looking for a linear function, we always just have to look for just the y equals mx plus b, or the x being next to the number, not on top, and there's no number on top of the x either. So if we look right now for our quadratics, we always have to look for the 2. If you look at A, the x has a 2. So this is going to be quadratic. If you look at C, there's also an exponent of 2 right there. So this is going to be quadratic. Same with D. There's a 2 up top, so that's quadratic. And lastly, we have E. The reason why we have E, there's no 2 in the top, but there's 2 x's. And when we multiply those together, it's going to give you x squared, which you would have that 2 in the top. If we move on to exponential, for exponential, I think it's the easiest one to find. It's just when we have an x on the top. So in this case, we have that x on the top. So we have f being the only exponential function of all of these we have here. And lastly, linear, this is y equals mx plus b, y equals mx plus b. Now we have to remember all the different types of functions and descriptions when we have a function. For example, and this is just a side note right here. Let's see if I can extend it. Yes. So for example, for exponential functions, those are the only type of functions that will have an asymptote. So if we look for anything such as the asymptote, that's just for exponential functions. When we look for, and that's about it. I mean, that's the main thing. When we look for quadratic functions, if we see the word vertex, that should automatically tell us that we have a quadratic function. And kind of looking parabola as well, if we see the word parabola, that means it is a quadratic function. You're not going to have a parabola with an exponential and a linear function. As well as, what's very important, for linear, it's the only one you have a constant slope. Constant slope, remember, that's when we have plus 2, plus 2, plus 2, plus 2, or minus 2, minus 2 every single time. Whereas for these, for exponential and quadratic, they're both ratios. Well, take that back. Exponential is ratio, and then this one doesn't have either or. So I guess I can go ahead and erase that because that only applies to exponential functions. All right, so now that I have those kind of cheat sheets, I can go ahead and start answering the questions. If I see question number 10, which one has an asymptote of 1? So remember when we talk about asymptotes, the word asymptote, that should already give us a hint that we are referring to exponential functions. Now, in this case, it's easy because the only exponential function we have would be x. Or sorry, f. So f goes here. Now, something else to know, that the asymptote is where the k is. If you look here, we have a plus 1. So that's why this is f. If we look for x-intercepts of x of 2 and negative 1. Now, when we are looking for 2 and negative 1, what I would always try to do is, that means that we're going to have a quadratic. The reason why we have a quadratic is because a quadratic has either two x-intercepts. It will either have 1 or 2. Linears will only have 1, and exponentials will only have 1 or none. So I guess we can put that for our quadratic functions as well. These will be the only ones that have 2 x-intercepts. So if we try to look for the one that has 2 x-intercepts, remember this is usually when x equals 2 and negative 1. So if we try to unsolve this, if you look at question E, when we try to solve this right here, x, the opposite of negative 2 is positive 2. The opposite of positive 1 is negative 1. So we already know E is one of the answers. Now, what I would do is check any other quadratic function that is not in intercept form and double check if that's not an x-intercept. Now, I can try to factor this out. When I do, I know that this is the same thing as x minus 2, x plus 1. If you recall back, you just have to do the big X. Negative 2 goes in the top. Negative 1 goes in the bottom. If we try to look for those two numbers, it will be negative 2 and positive 1. That's why those are our factored form. So you can see here, when you try to solve, A is also an equation. So that's for x-intercepts. Now we move on to constant slopes. Constant slope is anything that has a linear equation. So anything that has a linear equation will be a constant slope. So here we have linear equations, and so any one that is linear, in this case it's B and G. So we have B and G as our answer. Now if you read the questions above, it's talking about how we can have each function maybe used more than once. And then we move on to vertex. Vertex means that it is going to be a quadratic function. So what I would have to check first is check and see which one has vertex form. If we look here, this is H and that's K. So this is H and this is K. So we have 3, the opposite of negative of 3 would be negative 3 when we try to put it in vertex form, and that negative 5 stays the same. The only one that satisfies that would be C. So C is right there. Moving to question number 14, we has been shifted up 5 from its parent function. If you guys recall, for linear functions, going back here, for linear functions, the parent graph is y equals x. For quadratic is y equals x squared. And for exponential would be y equals, I guess this is a little bit different because your base can be anything, and then just x. So we are looking for one of the functions that has an up 5, a plus 5. In this case, the only thing that satisfies this equation would be D, because there's that plus 5 right there. So remember, this is D. Do you guys remember when we talked about quadratic functions? This would be a stretch by 3. This would be left 2, and that is up 5. Moving on to question number 15. Which one has been stretched by a factor of 5 from the parent function? Now, if you guys remember, the parent functions, just like we talked about when we had it in vertex form, we have that up, down, left, right. Negative means reflection, and when there's a number in front, it is a stretch. So we're going to look for a stretch of 5. So we want to see a 5 in the front. If you guys look here, there is a 5 in the front right there for C. So C is question number 15. If we move on to question 16, it's asking us about a parabola. When we talk about parabolas, that means we are looking for quadratic functions. Now, if it's opening down, that means it is sad. When it is sad, it is a negative equation. So anything that is negative would be the answer. In this case, this is negative here, and that's negative there. So our answer would be C and E. And that is question 16. If I move on to question 17, which one has been shrunk by the factor of 1/3? Again, when we are talking about shrink or shrunk, stretch, or shrink, we are talking about the number in the front. So all we have to do is look for the number that is 1/3 in the front. The only one that has a 1/3 would be this E right here. If I can take out that, let's see if I can move, there we go. So you can see that 1/3. Nothing else has a 1/3 in the front. So the only answer to this question would be E. If we move on to question number 18, it says which has a variable slope. Now, what both exponential and quadratic have similar is that they are both considered variable slopes. What does that mean? Variable slope just means that it is not constant. And if we talk about what constant is, it's the same. It is consistent. Constant means consistency. For linear, remember, we're going by the same number. Up to, or up 3, up 3, up 3, up 3, or down by the same number. Whereas for exponential, you don't go by the same number, and for quadratic, you don't go up or down by the same number. So every single time you see a variable slope, that is just pretty much anything that is not linear. So here I would make a note of that. So it is not linear. So any single function that is not linear up top, you would have that as your answer. In this case, it would be A, E, C, F, and D. Anything that is not blue. So I'm going to go ahead and write that down. It is A, C, D, E, and F. We move on to the question 19, which one has a left 2 at its parent function? Now, for the majority of them, when we talk about left 2, we usually talk about just the quadratic functions. So remember, if it's left 2, when we look at the vertex form, which is y equals ax minus h plus b, and this is squared here, this left 2 is the h right here. And it's when the h is positive. So when the h has a positive 2, that means we will have a left 2. In this case, our answer would be D. There's a plus 2 right there inside the parentheses. So this would be answer D. We move on to the very last question, which one has a y-intercept of 0, 2. So that just means that when x equals 0, y equals 2. So that one's pretty easy. All you have to do is pretty much put all x's for 0. So if I were to look at my questions, and I know it's very hard to do so since I've been writing all over them, but if I were to plug in a 0 for the x's, those would just be 0. And what would you be left with? In this case, just a negative 2. Now we're looking for 2, not negative 2. Same thing here. If I were to plug in 0 here, 15 times 0 is 0 plus 1. It'd just be 1. Same thing goes for question number C. All you have to do is just plug in 0, plug in 0, plug in 0. And when you plug in 0, you'll be able to find that the only answers that give you 2 are F and G. So F and G are the only questions or the only functions that give you 2 when you plug in 0. And you can just use your calculator for that. Let's see if I can pull it. I don't think I can. Let's see. Calculator. If I were to go to my graphing calculator, let's see if that works. Yeah, I can use my graphing calculator. So if I use my graphing calculator, which for you guys, you can just use any calculator you have, you can plug in any 0. So for example, if we look at question E, let's go to question A. So question A, we have x squared. So remember, we're plugging in 0 for that. Now this calculator looks a little bit different than yours, but it's essentially the same thing. And then minus x, which is 0, minus 2. Notice how you get a negative 2. And we don't want a negative 2. We want a 2. And you can do that for any single of them. We do f. 3 to the power of, there's an x, so we're going to put 0 plus 1. Notice how there, for your answer, you get 2. That is why f equals, or f is the answer to 20. If we look at G, we have 2 times x, which is 0, plus 2. When I plug that in, I get 2 as well. So that is why our answer is 2. Now, and I think that finishes the notes. Surely does. So I'm going to give you guys this video. You guys can check and see. I know it's a lot, but it's things that we've already covered. It's just everything is all together. So I'm going to give you guys this video, and then for the rest of the week, we're going to try to condense it down a little bit more. Hopefully, you guys will understand it a little bit better throughout this week. And then on Wednesday, I'm going to give you guys the homework. Thursday, homework as well. Friday is a catch-up day. And let's see if we can put a quiz for the following week. All right? So I think that is all for today. I'll see you guys tomorrow. Bye.